Thanks for taking the time to tune in to watch this solution. Just a quick note that if you're ever interested in any private tutoring, I do offer that service via Google Meet as well as through Zoom. And if you are interested, feel free to drop me a line at this email address right here and we can arrange a meeting. At this point, you might want to pause the video and reread the problem to reacquaint yourself with what's going on here. But in this problem, we are asked for the average acceleration of a ball during a particular time interval. Now, perhaps we've been learning about acceleration in our course, and we know that acceleration is defined as a change in velocity, so this would be a final velocity minus an initial velocity, divided by a time interval. Now, the time interval is given in the problem, but it's given in milliseconds. So just watch out. Often physics problems like to jumble the units, and you have to typically keep things in standard units. So perhaps our first step would be to convert the 3.5 milliseconds into the standard unit of seconds. And in this case, you're going to need to know your metric prefixes. So on the side, we might note that 1 milli, any quantity, it doesn't matter if it's milliseconds or millimeters, but 1 milli anything is equivalent to 10 to the negative 3 of that quantity. So if it were 1 millisecond, it would equal 10 to the minus 3 seconds. So that's the conversion we're going to be using. On the bottom, we're going to say 1 millisecond, and then on the top, we're going to do 10 to the negative 3 seconds. And we set it up in this fashion so that the milliseconds would cancel out. Now you could put that into a calculator, and if you did that, you would get a time interval of 0.0035 seconds. So that's good. We've got the time interval figured out. But now let's talk about the final velocity and the initial velocity. We need to be a little careful here as well. And let's make some room. And that's because the ball is rebounding. So imagine that you have a ball that is initially traveling to the left. And typically, if you have an object that's traveling to the left, then we assign a negative for that velocity. So that would mean that the initial velocity would be negative 25 meters per second. But then after rebounding, the ball would be traveling in the opposite direction. It would be traveling to the right, and to the right would be the positive direction. So the final velocity would equal 22 meters per second. So when students solve this type of problem, in which an object is rebounding, they often neglect the change in direction. They often neglect the negative that we assign to that initial velocity. So let's come down here and start plugging in all of the values that we have stated. So again, the final velocity, which I've already forgotten, was 22 meters per second. So we'll put that in for the final velocity, subtract the initial velocity, which I've also forgotten, which was negative 25 meters per second. It's not easy to talk and recall all the details at the same time. And then we divide that by 0.0035 seconds. So at this point, you can put that into your calculator. And when you do that, you're going to get 13,429 approximately meters per second. So that would be the correct answer. If you want to get a little bit fancy and use scientific notation, you can take the decimal point, which is located here, and move it over 1, 2, 3, 4 places to the left. So that would be 1.34 if we round. And then to put the decimal place back to where it was, you have to move it back 4 places to the right. So 4 places to the right would be a positive 4 in the exponent. And that would be an alternative version of the correct answer. So either way, this should work.